Have you ever seen a ship that does not touch the water? Now, imagine that such a vessel not only exists, but can also carry tens of tons of cargo and accelerate up to 250 miles per hour. Meet the Hovercraft landing craft, a unique combat vehicle that glides above water, land, sand, and even ice. Its engines are just like those in fighter jets, and its maneuverability lets it drift on waves. But how much does this technology cost? How do they build it? And why are even seagulls afraid of these machines? Let's find out. The idea of using an air cushion came from the British engineer Christopher Cockerell in the 1950s. He experimented with airflows using tin cans and a hairdryer, ultimately creating the concept of a vehicle that could glide over any surface. In 1959, the world's first real hovercraft was launched. Later, this technology found its way into military use, specifically in LCAC-type landing crafts developed in the United States during the 1970s. So, Cockerell invented it, but the military refined the idea into its modern form. Let's move forward. Or maybe sail ahead. Manufacturing hovercraft landing crafts involves several stages. Initially, design bureaus create drawings and digital models of the craft. The design process depends on whether it's a new project or an upgrade of an existing one. Creating a completely new hovercraft takes from 6 to 12 years. Imagine that. Preliminary design and concept stages last from 1 to 3 years. Developing drawings and digital models adds another 2 to 5 years. Building and testing the prototype takes an additional 3 to 5 years. Finally, we get a ready-to-use craft. If we're talking about upgrading an existing design, the process takes half the time. Analysis and adaptation of drawings take from half a year to 1 year. Updating digital models takes only 1 or 2 years. Building and testing the updated version takes 2 to 3 years. The newest American hovercraft, called the Ship-to-Shore Connector, replacing the LCAC, began development in the 2000s. The first test models were ready in 2012 and 2014, but full-scale production started only in the 2020s. The process is lengthy because these crafts must be reliable, fast, and suitable for challenging operational conditions. After drawings and digital models are developed, suppliers of materials and components are selected. The military announces tenders, where companies compete for contracts. Manufacturers must pass certification and prove their materials withstand extreme conditions. Some components are produced exclusively domestically for national security. Thus, the process is complex but critically important. If even one component fails, the entire mission can be jeopardized. The craft's frame is assembled at shipbuilding yards. These massive industrial complexes are usually located on coastlines or near large rivers. They cover areas from dozens to hundreds of acres, since multiple vessels must be built simultaneously, with space for storing materials and heavy equipment. There are huge covered or open areas where ship hulls are assembled. These areas can be from 500 to 1,500 feet long to accommodate large structures. In metalworking workshops, aluminum alloys for the LCAC hull are cut, welded, and shaped using robotic machines and laser cutting. Shipyards also include dry dock basins, enormous artificial pools, where finished crafts are tested before launching. Massive gantry cranes with lifting capacities from 100 to 1,100 tons move large sections of hovercrafts. Additionally, there are areas for installing gas turbine engines, radar, and navigation systems, as well as logistics yards, where incoming materials and components from suppliers are stored. One of the largest such shipyards in the United States has been building military vessels for more than 100 years. The frame assembly of a hovercraft landing craft is constructed mainly from aluminum alloys, using welding and assembly methods different from traditional shipbuilding. Aluminum sheets and profiles are supplied as ready-made blanks. Robotic machines cut out parts according to computer-generated drawings. Sections for the future frame are prepared in special workshops. The LCAC structure is not assembled entirely at once, but built from large modules. Each module, for example, the bow, stern, and side sections, is assembled separately. Rivets and aluminum welding ensure durability. The frame consists of a keel beam running the length of the craft and transverse ribs providing rigidity. Aluminum rivets and specialized adhesive mixtures are used to connect sections, reducing weight. Large modules are lifted by powerful cranes and connected precisely using laser positioning to avoid errors. At the brightly illuminated shipyard, a giant module of the future craft rises into the air. A heavy gantry crane, weighing hundreds of tons, slowly lifts the aluminum section, gleaming in the sun like the shell of a marine predator. Metal cables are stretched tight like strings, while workers in protective helmets and vests carefully monitor every movement. The enormous part floats mid-air, gently swaying in the breeze. A crane operator, sitting high above the yard, maneuvers this colossus with extreme precision. Engineers below signal instructions, guiding the module to its exact position. When the section slowly settles into place, there's a dull metallic thud. Thousands of pounds of aluminum collide with the frame. Immediately, fastening begins. Workers tighten bolts, welding machines ignite with bright blue flames, and sparks scatter from beneath electrodes. The air fills with the scent of hot metal as the craft gradually takes shape, becoming a formidable combat machine. Engineers inspect structural integrity and tightness. Attachment points for the hovercraft skirt are installed on the frame. This system must be completely airtight to maintain LCAC stability during movement. The completed frame undergoes load and vibration tests. After passing successfully, engines, propellers, and electronics are installed. Now begins one of the most critical stages. The shipyard hums with crane motors, gently transporting massive gas turbine engines, the heart of the future craft. Workers dressed in protective suits and masks precisely position them in compartments, where every millimeter counts. Simultaneously, technicians attach enormous propellers, blades made from robust composite materials, which will later propel air with thousands of horsepower. When blades rotate for the first time, air waves ripple through the air, causing fabric on work uniforms to tremble. Inside, engineers connect cables, sensors, and onboard computers, carefully inspecting every chip, screen, and controller, as navigation, communication, and automated control depend on these systems. Once everything is ready, the moment of truth arrives. Pressing the first launch button, the massive frame shudders, turbines roar to life, and the first stream of hot air bursts from exhaust channels. The LCAC is ready for its first water test. A single modern LCAC costs from $50 to $75 million, depending on modifications. Operating costs are high due to gas turbine engines and demanding maintenance. Maintenance can occur at shipyards or specialized bases. Gas turbine engines require frequent service due to limited lifespans and costly repairs. The hovercraft skirt wears from contact with water, sand, and stones. Propellers and air systems require repairs as they operate continuously at high speeds. The United States is the leading producer of the new Ship-to-Shore Connector crafts, replacing older LCACs. Great Britain builds similar crafts for civilian and military markets. Who uses them, you might ask? The United States Navy is the largest operator, possessing about 70 LCACs and acquiring new models. Japan uses LCACs for defense and humanitarian missions. Potential customers include NATO countries and nations expanding amphibious forces, like India and South Korea. Currently, LCACs are being upgraded to SSC, quieter, faster, and more efficient crafts. Demand is rising due to threats in the Pacific region and the need for rapid troop transport. Additionally, LCACs can drift. With the air cushion, they lack typical friction with water or land, allowing them to slide sideways, sharply change direction, and even pivot almost in place, making them exceptionally agile but challenging to control. LCACs use the same gas turbine engines as military aircraft, specifically the General Electric LM2500. Similar engines power F/A-18 Hornet fighters. Essentially, LCACs are aircraft that never leave the surface. Unlike conventional ships, they can move onto shore, cross sandy dunes, swamps, and even ice, providing advantages for landing troops in difficult locations. However, LCACs are among the loudest vessels in naval forces. Their noise can be heard hundreds of feet away, making them unsuitable for stealth missions. During operation, LCACs create powerful vortices, capable of literally blowing away seagulls and other marine birds, often making it impossible for them to remain airborne. Every day in the United States, folks toss out 27,000 microwave ovens. That's nearly 2.5 million a year. But what happens to them once they're kaput? You'll be shocked at how wild the recycling process gets. From tearing apart transformers packed with hazardous stuff to digging out gold from circuit boards, every step is a jaw-dropper. How do factories handle hundreds of tons of metal daily? Why do magnetrons need special treatment? And what's the deal with the plastic parts? Stick around to the end to uncover the secrets of e-waste recycling. Recycling microwave ovens in the United States of America is a tricky business, involving a bunch of steps, all geared toward cutting down environmental harm and squeezing every bit of reusable material out of them. It all kicks off with properly disposing of the oven according to local rules and laws. Tons of towns have special e-waste drop-off spots where people can hand over their old appliances. Plus, big retail chains and microwave makers often run take-back programs, sometimes even tossing in discounts on new buys as a sweet deal. Once the thing lands at a recycling center, the first move is breaking it down and sorting out the main parts. This happens at specialized e-waste recycling hubs, or appliance recycling plants. These places are scattered across the United States, mostly clustered in industrial zones or near big cities where electronic junk piles up fast. Some are private outfits, while others roll under city-run recycling efforts. First off, workers figure out if the oven can be reused or if it's headed for a full teardown. If the microwave's in rough shape, it goes straight to the disassembly line. They start by yanking off the outer shell, usually made of steel or aluminum. Breaking down microwave ovens can happen by hand or with machines. In smaller recycling spots, most of the work's done manually with basic tools like electric screwdrivers, pliers, hydraulic shears, and teardown stations. They unscrew the outer metal panels first, popping open access to the guts inside. Workers pull out the big pieces, like the magnetron, transformer, circuit boards, and wiring. The metal bits get squashed and shipped off to steel mills, where they're melted down for reuse. Inside every microwave is a magnetron, the thing that pumps out those microwaves. It's got ceramic insulators, copper coils, and a tiny bit of toxic stuff, like beryllium. Since beryllium dust can be nasty, magnetrons get handled with care, using protective gear and special recycling tricks. At big industrial recycling centers, they roll out automated teardown lines. A key player here is the electronic shredder. Think machines like the hammer mill or SSI dual shear, stretching 15 to 20 feet long and chewing through hundreds of microwaves an hour. After shredding, the materials hit magnetic separators, which pull steel apart from the rest. At heavy-duty plants, teardown's a multi-step gig with fancy machines. For transformers, they use hydraulic cracking presses to bust open the casing and get at the copper or aluminum windings. To snag precious metals from circuit boards, they dunk them in chemical baths or fire them up in furnaces at over 2,000 degrees Fahrenheit to melt out the good stuff. On average, big plants can rip apart 500 to 1,000 microwave ovens a day, depending on how much gear comes in and how automated they are. At smaller outfits, where it's mostly handwork, they process 50 to 200 units daily. Next, they yank out the circuit boards, loaded with resistors, capacitors, and microchips. These get handed off to companies that extract precious metals like gold, silver, and palladium. The copper wiring inside gets peeled out and recycled too. While exact numbers on precious metals from microwaves in the United States are hard to pin down, e-waste recycling overall brings a hefty haul of valuable materials back into the game. Another big piece is the high-voltage transformer, made of a metal core and copper or aluminum windings. Since it's got insulation that could be risky, recycling it takes some extra steps. The main hassle with transformers is their density and toughness, making it a chore to pull out the materials fast. Teardown starts by prying the transformer loose from the microwave's shell. This happens manually or with electric screwdrivers and teardown stations. Then it's hauled to the recycling zone. If it's by hand, workers use hydraulic shears, grinders, or metal cutting presses to slice open the outer casing. The transformer's core, usually layered steel, needs serious muscle to split, so big plants lean on industrial shredders or hydraulic presses. One slick way to crack transformers is with special crushing presses that smash the casing, letting workers fish out the insides. After that, the copper or aluminum windings get peeled off the core and sent for melting. Magnetic separators sort out the steel from the rest. Shredded bits ride a conveyor belt, and as they pass under a magnet, ferromagnetic stuff, like steel plates and transformer cores, sticks to it, then drops into a separate bin. Another type, the drum magnetic separator, uses a spinning magnetic drum. Shredded materials roll onto it, and magnetic force grabs the iron bits, spinning them along until they fall off into their own container once they're out of the magnetic zone. Beyond the mechanical approach, some plants use heat to break down insulation. Transformers get roasted in special furnaces at 1,000 to 2,000 degrees Fahrenheit to burn off organic junk and free up the metals. In some cases, they go with chemical leaching, soaking the transformer in acid or alkaline baths to dissolve certain parts. Extra caution's needed with the insulation, since it might hold toxic stuff. Older models, for instance, used varnishes with polychlorinated biphenyls, nasty chemicals. So recycling those means wearing protective gear and sending the waste to special hazardous material plants. One slick way to crack transformers is with special crushing presses that smash the casing, letting workers fish out the insides. After that, the copper or aluminum windings get peeled off the core and sent for melting. Magnetic separators sort out the steel from the rest. Shredded bits ride a conveyor belt, and as they pass under a magnet, ferromagnetic stuff, like steel plates and transformer cores, sticks to it, then drops into a separate bin. Another type, the drum magnetic separator, uses a spinning magnetic drum. Shredded materials roll onto it, and magnetic force grabs the iron bits, spinning them along until they fall off into their own container once they're out of the magnetic zone. According to the United States Environmental Protection Agency, about 25% of e-waste, including microwave ovens, gets recycled. Every day, around 27,000 microwaves get retired across the United States, adding up to roughly 2.5 million a year. Recycling cuts down on landfill clutter, helping keep soil and water free of toxic leaks from electronic gear. Properly handling hazardous parts, like capacitors or insulation, stops harmful stuff from hitting the environment, which is a win for people's health and ecosystems. Imagine this. By 2030, the entire world could be threatened by over 12 million short tons of spent lithium-ion batteries. But what actually happens to electric vehicles once they reach the end of their service life? It is not just simple disassembly. It is a high-technology process where even the remaining battery charge is used to power industrial facilities. Meanwhile, steel, aluminum, and plastic go right back into manufacturing, giving a new life to old automobiles. Watch until the end. You will be surprised by how efficient this recycling has become. The cost of electricity for charging is significantly lower than the cost of gasoline or diesel fuel, and the motor runs rather quietly. This, of course, increases the comfort of the ride. The most popular models are produced by Tesla, but there are many other manufacturers on the market, including Nissan, BMW, Audi, Mercedes-Benz, Volkswagen, Porsche, Rivian, Ford, General Motors, and Hyundai, which is quite a lot. However, even an electric vehicle eventually reaches the end of its service life. When the vehicle arrives at this end, it is sent for recycling. First, the car is deregistered, and then it is taken to special facilities that handle disassembly and recycling of vehicles. These can be recycling centers, auto dismantling sites, or recycling factories. Vehicles may be delivered by the owners themselves or by dedicated services that pick up damaged or non-operational cars. Some facilities work with insurance companies or government organizations that coordinate disposal programs. When the car arrives at the site, it is initially inspected to determine which parts can be reused and which must undergo complete disposal. The site is typically an area equipped with bays or specialized zones where all processes take place. Mechanics and equipment operators work here, removing vehicle components both manually and with the help of machines. First, all technical fluids are drained. The car is placed on a special lift or in a separate drainage area. Operators use pumps or remove drain plugs to extract motor oil, transmission fluid, antifreeze, brake fluid, and fuel. The fuel is pumped out with vacuum systems to prevent fire hazards, and the motor oil is collected in containers for later recycling. After that, the disassembly of the vehicle begins. The battery is removed first and sent to a separate recycling process. There, it is tested to determine the level of remaining charge and suitability for reuse. The removal must be done carefully, as the battery contains toxic and flammable materials. This can take from 30 minutes to 60 minutes by itself. If the battery can still hold a charge, it is used in stationary energy systems, for example, to store energy from solar panels. If the battery is completely worn out, it is sent for disposal. To monitor battery condition even before disposal, Tesla, for instance, uses its own software that can remotely evaluate the remaining capacity, the level of cell degradation, and the overall condition of the vehicle's energy system. This makes it possible to determine whether the battery can be used in secondary energy applications or must be fully disassembled. Through this approach, the company reduces the number of batteries immediately sent for disposal, extending their life cycle as stationary energy storage systems for as long as possible. The recycling of Tesla electric vehicles happens in much the same way as the recycling of other electric vehicles, but there are certain specifics due to the battery design, the body materials, and the software. Tesla batteries have a complex modular structure and a high energy density, requiring additional safety measures, including a complete discharge and controlled disassembly. A full discharge of a Tesla battery is carried out at specialized recycling centers, where strict safety measures are followed to avoid the risk of fire or explosion. This is done using special equipment that gradually removes any leftover electrical energy, placing the battery into a safe state. Because lithium-ion batteries maintain a high energy density, they can still hold a substantial charge even after extended use, making the discharge process critically important prior to further recycling. According to estimates, by the end of 2030, around 12 million short tons of spent lithium-ion batteries could end up in landfills if effective recycling systems are not put in place. To discharge the battery, industrial systems of controlled power consumption are connected, gradually drawing off the remaining energy. These machines operate on the principle of creating a controlled electrical load, simulating energy consumption, where electrical energy is converted into heat that is then dissipated by active cooling systems. Another method involves connecting the battery to industrial energy storage systems, which can use the residual charge to power facilities or feed electricity back into the grid. The process occurs in a controlled environment with low humidity to minimize the risk of corrosion and unwanted chemical reactions. The temperature is maintained between 50 degrees Fahrenheit and 68 degrees Fahrenheit because higher temperatures can accelerate degradation of battery cells, while lower temperatures increase the risk of electrolyte instability. The operator oversees discharge parameters through computerized monitoring systems, which record voltage, current, and battery temperature in real time. Once the charge falls to a safe level, typically below 1% of the original capacity, the battery is considered discharged and ready for further disassembly. The battery is taken apart, separating the casing, modules, and electronics. Each module consists of thousands of lithium-ion cells that must be properly recycled to recover valuable metals. The modules are mechanically shredded in specialized installations that operate in an inert gas environment or under liquid nitrogen to prevent spontaneous combustion of any leftover active materials. The resulting shredded mass undergoes either thermal treatment or chemical solutions to remove organic components such as electrolyte and binding substances. After processing, the recovered metals are reused in the production of new batteries, and the remaining materials are disposed of in accordance with environmental standards. Toxic waste is neutralized at specialized facilities. Currently, only about 5% of lithium-ion batteries are recycled worldwide, indicating a major opportunity to improve recycling infrastructure. One key method for recovering valuable materials is hydrometallurgy. This process involves dissolving shredded elements in specialized chemical solutions that allow for the separate extraction of nickel, cobalt, lithium, and other metals. Compared to the traditional pyrometallurgical method, which uses melting at high temperatures, hydrometallurgy is more energy efficient and environmentally safe because it allows the extraction of pure metals without significant air emissions. Thus, the batteries are disassembled, casings and electronic components are recovered, and then the active electrode material is shredded. The resulting shredded mass is referred to as black powder, as it contains oxides and other metal compounds. Next, this powder is dissolved in an acidic environment, using for instance sulfuric or hydrochloric acid. This stage is known as acid leaching, during which the metals convert into a solution. As a result, a liquid mixture forms that contains ions of lithium, nickel, cobalt, and other elements. The next step is extraction and selective precipitation. Using reagents such as organic extractants or precipitating agents, specific metals are extracted from the solution. For example, lithium may be precipitated as lithium carbonate or lithium hydroxide, both of which are used in the production of new batteries. Nickel and cobalt can be extracted by altering the alkaline solution or by precipitation using sulfides and hydroxides. After precipitation, the metals undergo additional purification, including filtration and recrystallization. The end products, metal salts or metal oxides, are sent back into production for new battery cathode materials. The efficiency of hydrometallurgy makes it possible to recover over 90% of nickel, cobalt, and manganese, as well as up to 90% of lithium. This significantly reduces the need to mine new resources and promotes a closed-loop battery manufacturing cycle. After disassembling and processing the batteries, the electric vehicle recycling process continues. The motor and transmission are removed if they are suitable for reuse or repair. This can be done by people manually, using wrenches, jacks, and other tools, or by robotic systems that simplify the process. Wheels, radiators, electronics, and glass are also removed, and these components can be sold separately or recycled. Window glass, for instance, is recycled by shredding it into granules, which are then used in construction or to produce new automotive glass. Plastic components, such as bumpers, interior panels, and fuel tanks, are processed by shredding and later used to create new products. Only when all valuable and hazardous components have been removed from the car do they proceed to recycle the body. It may be cut into large pieces using hydraulic shears or sent directly to a shredder. Shredders reduce the metal frame to small fragments, which are then sorted by material type. Steel and aluminum are separated using magnets or electronic sensors, after which they are sent for remelting. Those parts of the vehicle that cannot be recycled may be disposed of by incineration to produce heat energy, or buried at specialized landfills. The entire process can take anywhere from a few hours to several days, depending on the type of vehicle and the level of automation at the facility. However, with modern technology, the percentage of materials that can be reused is constantly rising, and it currently exceeds 3/4 of a vehicle's total mass. Do you know what can amaze you even more than the flight of an airplane itself? It's life after the sky. Every year, thousands of airplanes are retired worldwide, and some of them become a source of metal for new automobiles or even construction frameworks. One single Boeing 747 contains around 165,000 pounds of aluminum, which can become the future raw material for dozens of other airplanes. Are you curious to learn how engines, which can cost up to $30 million, get a second lease on life? or how first-class seats turn into part of a home movie theater setup. Are you ready to journey into a realm where technology, ecology, and business converge in one enormous hangar? Let us take off and explore. The first step in a retired airplane's journey is what insiders often call its removal from flight. In fact, this phase is sometimes referred to rather poetically as heading into retirement. Airplanes are retired when they reach a certain age, a certain number of flights, a certain tally of hours in the air, or when they simply become economically unviable to operate. Passenger airplanes typically serve from about 20 years to about 30 years. The metal gradually becomes fatigued from the repeated cycles of takeoff and landing, alongside the persistent air pressure at cruising altitudes. Engineers may detect microcracks or other structural issues, making further flights risky. Older airplanes require more frequent maintenance, which becomes expensive. Eventually, the costs of upkeep can overshadow any profit from keeping that aircraft in service. More modern airplanes consume less fuel, are cleaner for the environment, and cost less to operate. For instance, contemporary designs, such as the Boeing 787 or the Airbus A350, are far more efficient than older airplanes like the Boeing 747. International safety standards also keep shifting. If an airplane does not meet new standards and modifications prove too pricey, that airplane is retired. Occasionally, airlines retire airplanes because travel demand declines. During the coronavirus disease 19 pandemic, many older airplanes were retired ahead of their original timelines. Interestingly enough, cargo airplanes can keep flying for a longer period as there are fewer requirements for passenger comfort, and their overall load can be lighter. Yet, sooner or later, even cargo airplanes head into retirement. Once an airplane is ready for disassembly, it is towed to a specialized hangar, where its second chapter really begins. The first priority is the engines. They are, beyond any doubt, the most valuable part. Engineers remove them first, perform detailed inspections, and then either overhaul them for reuse or break them down for spare parts. One of the staff members told me that a single engine can be more expensive than the entire airplane. Can you imagine that? The process starts with engineers reviewing the documentation for both the airplane and the engine. They want to know its overall condition, its servicing history, and whether any special precautions are needed. All fuel, hydraulic fluid, and lubrication systems in the engine are de-energized, with every liquid drained. This step is crucial, since even small amounts of leftover fuel or oil can be a fire hazard. The engine is linked to the airplane by dozens of cables, pipes, and mechanical connections. One at a time, engineers disconnect the electronics, hydraulic lines, and ventilation and cooling systems. All connectors are labeled so that they can be quickly identified whenever the engine is inspected or installed on a different airplane. The cowling is the protective shell around the engine. It is taken off to reach the main components underneath. This cowling is removed very carefully and often sent away on its own for inspection or repair. Engines can weigh several thousand pounds, so they must be firmly supported before removal. Specialized lifting platforms or cranes are used to ensure the engine remains undamaged during detachment. Engines are attached to the wing or fuselage by pylons, which are special mounting structures. Engineers gradually remove these attachments, frequently by hand, using high-precision tools. It is a delicate moment, since a slip can cause damage. Following removal, the engine travels to a service facility for inspection, repairs, or further disassembly. It is secured in a dedicated container that safeguards every part during transport. The engine is the priciest piece of the airplane. Depending on the particular model, it may cost anywhere between $10 million and $30 million. As a result, the removal process is carried out with extreme caution. Often, an engine is not taken off because of a failure, but rather to undergo planned maintenance, or so it can be installed on another airplane. In many cases, engines embark on a new life after refurbishment and upgrades. This underscores yet again that aviation is not just about flying, but also about pragmatic reuse and a certain technological artistry. The next thing that amazed me was the fuselage. The aluminum body of an airplane is not simply chopped into random pieces. Instead, it is sorted, cleaned, and directed toward recycling. This metal can be reborn as part of new airplanes, car parts, or even building materials. By the way, have you ever wondered how much aluminum is inside a single Boeing 747? It is about 165,000 pounds, which is impressive to envision. That quantity could practically spawn an entire fleet of future airplanes. Seats, which we usually see as nothing more than comfortable chairs for our flight, can also be reincarnated. They are repaired and sold to airlines that have tighter budgets. Sometimes they even end up with private buyers. Did you know that first-class seats can be purchased for a home movie theater? That idea is definitely on my personal wish list. Aviation electronics form another treasure trove. Every component, from onboard computers to navigation systems, is extracted and carefully evaluated. These parts often see further use in pilot training simulators or get integrated into other airplanes. Even seemingly small items, such as life vests, seatbelts, or tableware, find new owners. Some of them are turned into unique souvenirs. Do you recall those movies in which people collect aviation memorabilia? That is actually based on reality. Aviation collecting can be quite costly. For instance, the nose section of an airplane or an antique propeller can sell for thousands of dollars. If a piece is historically significant, say it comes from an airplane involved in the Second World War, its value could multiply dramatically. The aspect that left me most astonished was the team's flawless coordination. They moved as if they were dismantling a gigantic construction set, with each part assigned its own special place in the bigger picture. It was almost like a dance involving both machinery and people, all working in harmony to accomplish something meaningful. Think about it. A single airplane can yield up to 50,000 parts. Someone has to track each nut, each bolt, and each panel, making sure everything lands in the right container. Logistics teams then see to it that no part gets lost and that every component reaches its intended destination, whether it is a repair center or a recycling facility. Disassembling an airplane is definitely not a matter of taking it apart and forgetting about it. Proper disposal protocols must be followed for all hazardous substances, such as unused fuel, hydraulic fluids, and batteries. Environmental teams and safety inspectors ensure that every step complies with regulations and safeguards the planet. Having witnessed all this, I am convinced that aviation is so much more than just flying. It is about ecology, business, and even a touch of art. Now, whenever I look up and see an airplane cutting across the sky, I find myself wondering what the future holds for it. How about you? So the next time you watch an airplane soar overhead, remember that even after its final flight, it can transform into something far greater. Imagine this. Every minute, over 70,000 Oreo cookies are sold worldwide. That's enough to circle the Earth more than 400 times. But what makes them so insanely popular? How do they create that legendary flavor and perfect texture, loved in over 100 countries? Today, we're stepping behind the scenes at one of the world's most famous factories to uncover all the secrets behind this iconic cookie. From its unique design to the creamy filling, let's dive in. The Oreo recipe was first created back in 1912 at a factory in Manhattan. To this day, it remains the most popular cookie in the world. Since its inception, more than 500 billion Oreos have been sold. If you lined them all up, they'd wrap around the Earth over 400 times. Oreo is also one of the most active brands on social media, with over 40 million followers on Facebook and millions of fans on TikTok and Instagram. Campaigns like Twist, Lick, Dunk have gone viral in countless countries. It all begins with high-quality ingredients. Oreo uses premium-grade flour, cocoa powder, sugar, vegetable oils, and a secret blend of flavorings that make every batch unmistakable. But let's face it, ingredients alone aren't magic. They're mixed in precise proportions to form the base for the cookies. Inside the factory, massive mixers, capable of handling hundreds of pounds of dough at a time, work like a culinary orchestra, fast yet precise. Here's where the first secret lies: the cocoa. Oreo uses a specially processed cocoa powder that gives the cookies their rich, deep black color. And no, that shade isn't just from the chocolate. It's the result of a meticulously fine-tuned chemical process. Once the dough is ready, it's time to shape the cookies. This is where a high-tech conveyor system with custom molds steps into action. Yep, every Oreo cookie features a unique pattern, and it's not just for decoration. Each cookie's design is perfectly symmetrical, with 12 flowers, 12 dots, and 90 ridges around the edge. This iconic design hasn't changed since 1952, the year of its one and only redesign. The texture plays a big role in the overall taste experience. The smooth edges hold the cream in place, while the tiny puzzle-like details add that signature crunch. Here's a fun fact. The machine that stamps the cookies can churn out up to 3,000 pieces per minute. Imagine that pace. Every single detail has to be flawless. Baking Oreos is a true science. The dough travels through an oven line that stretches up to 245 feet long, with the temperature monitored literally at every inch. First, a high temperature helps the cookie hold its shape, and then it's gradually reduced to prevent overdrying. The result? That perfect balance of a tender texture that melts in your mouth while staying satisfyingly crunchy with every bite. Now, let's move on to the filling. The cream for Oreos is made separately, and this process? It's nothing short of modern-day alchemy. Massive mixers whip the cream filling to the perfect consistency you know and love. Here's a little secret. The cream isn't just spread on. It's piped through special rotating nozzles to ensure an even layer. For the classic Oreo, that's a vanilla cream filling. But you already know how many flavors are out there today, right? From strawberry to mint chocolate, each new flavor undergoes rigorous testing before hitting store shelves. The formula for Oreo's cream filling is top secret, with only a handful of people in the world knowing the exact recipe. Now comes the most magical part, joining the two cookie halves. This process, called sandwiching, is performed with incredible precision by machines. Fun fact, every other cookie half is flipped upside down to ensure a smooth connection with the cream. And just like that, in seconds, the iconic sandwich is born, ready to enjoy. Studies show that around 50% of people twist apart their Oreos before eating them. Even more folks dip them in milk. In fact, Oreo is officially considered the perfect cookie for milk. Scientists have even experimented to find the optimal dunk time, 4 seconds. That's just long enough for the cookie to maintain its crunch while melting in your mouth. Every hour, over 1.5 million Oreos are produced in factories worldwide. Once the cookies are ready, they're sorted and sent to the packaging line. Quality checks happen every single time. And yes, there are imperfect cookies. They're sorted out and sent for recycling. Curious how Oreo stays so fresh in its packaging? It's all thanks to vacuum sealing. The packaging is specifically designed to preserve texture and flavor. It's made of multi-layered materials that keep out moisture and air, ensuring the cookies stay crispy. The outer layer of polypropylene provides durability, while the inner layer creates a barrier to protect against oxidation. The key to Oreo's packaging is the vacuum seal. Once the cookies are packed, excess air is removed from inside the bag to eliminate contact with oxygen. This keeps the cookies fresh for up to 9 months, or even longer. Each package is precisely cut to size using high-precision lasers, guaranteeing an airtight seal. You've probably noticed how easy it is to open modern Oreo packages. That's thanks to the peel and reseal closure, which allows you to open and close the package multiple times. This way, the cookies stay fresh even after the first opening. Oreo offers a wide range of packaging options so everyone can find their perfect fit. Standard packs, a classic for the home. Mini Oreos, small, snack-sized packs perfect for on-the-go munching. Mega packs, ideal for those who just can't get enough. And let's not forget individual packs of 2 or 3 cookies. Super convenient for the office or a lunchbox. That iconic blue packaging? It's no accident. The color is associated with freshness, lightness, and happy emotions. Each pack features a photo of the cookie with milk, sparking instant cravings. In some countries, Oreo even includes interactive packaging with QR codes, leading to games, recipes, or videos, adding an extra layer of fun. Recently, Oreo has been working hard to make its packaging more eco-friendly. In 2023, the company began testing recyclable materials for its packs, aiming to reduce the carbon footprint of production. In some countries, fully recyclable packaging is already in use. After packaging, the packs go through special scanners to check for weight and airtight seals. If even the smallest defect is found, the package is pulled from the line. Oreo uses specialized refrigerated containers during transportation to prevent temperature fluctuations. This ensures the filling's texture and the cookie's crunchiness are perfectly preserved. Did you know Oreo is made in over 50 countries and sold in more than 100? Every day, more than 40 million cookies are produced. That's more than the population of some countries. Interestingly, recipes and flavors can vary by region. For example, green tea flavor is a hit in China, while caramel fillings are a favorite in Latin America. Oreo has even been to space. In 2021, the brand sent its cookies to the International Space Station as part of a promotional campaign. And back in 1992, musician Weird Al Yankovic released a song called The White Stuff, a parody of New Kids on the Block's The Right Stuff. The song? A hilarious ode to the creamy filling of Oreo cookies. One of the most creative and fun marketing initiatives by Oreo is the Oreo Stacking Championship. The rules are simple. Participants compete to see who can build the tallest tower of Oreo cookies before it topples. But like everything Oreo touches, this competition transforms into a full-blown event, complete with heroes, records, and even a little drama. The current world record for stacking Oreo cookies stands at 54 cookies in a single tower. This record was set back in 2018 by an American at a local festival in Texas. Typically, records in these competitions range between 30 and 50 cookies because each additional layer makes balancing the structure even harder. Thanks to the cookie's round shape, towers often collapse at the most nerve-wracking moment, when someone tries to add that final cookie. It's all in good fun though, and the laughter from the audience and participants is infectious. At one championship in Japan, the winner was an 85-year-old grandma. She credited her victory to age bringing calm and patience. Oreo is officially recognized as the most popular cookie in the world, outselling all competitors in the cookie and dessert category. What makes Oreo so special? It's not just the flavor and texture, it's the emotions they spark. Admit it, you twist the cookie apart before eating it, right? Or maybe you dip it in milk. In the US, there's a cult-followed ritual for eating Oreos. Twist, lick, dunk. The process involves separating the cookie, licking off the cream, and dunking the rest in milk. Interestingly, women are more likely than men to take their Oreos apart before eating. It's this simplicity and versatility that have made Oreo a favorite for millions. It's a cookie that brings people together because everyone finds their own way to enjoy it. You have no idea what's behind every sweet bar of Snickers. Today, you'll step into the secret workshops, see robotic machines, and discover genius engineering solutions that bring your favorite candy bar to life. We'll uncover shocking facts about nougat, caramel, and peanuts, and show you how that crunchy chocolate layer is born. Stick around till the end, and you'll never look at a Snickers the same way again. Get ready for an explosion of flavor and technology. Snickers was created in 1930 by Mars Incorporated. The bar was named after the Mars family's favorite horse. Since then, Snickers has become one of the world's most popular chocolate treats, sold in more than 80 countries. But making Snickers isn't just about mixing ingredients. It's a precise, high-tech, and incredibly fascinating process. The first step in making a Snickers bar is preparing the ingredients. The main components are nougat, caramel, roasted peanuts, and milk chocolate. If you're like me and didn't know what nougat is, it's a mix of sugar, protein, and fat. Caramel is made from melted sugar and milk, and milk chocolate combines cocoa, milk, and sugar. The roasted peanuts are specially treated to ensure the perfect crunch. Every ingredient is top-notch. For example, peanuts are purchased in massive quantities and carefully sorted so only the best nuts make it into the bar. Let's take a closer look at the ingredients. Nougat forms the base of the bar. It's made in giant mixers where sugar, glucose syrup, egg whites, and fats are whipped together. Flavorings are added to give the nougat its distinctive taste. The finished nougat is rolled into long ribbons. This process of rolling nougat into ribbons is a true demonstration of engineering mastery. The soft, warm nougat is handled by special machines. First, the nougat is loaded into an extruder. a machine that pushes it through openings to form long uniform strips. Think of it like a giant piping bag at a bakery, but on a factory scale. Pressure and temperature are carefully controlled to keep the nougat pliable but intact. After extrusion, the ribbons move onto a conveyor belt where rollers even out their thickness. These rollers are like massive kitchen rolling pins that gently press the nougat, ensuring consistent thickness throughout the ribbon. To prepare the nougat for the next steps, it's cooled using ventilation systems or cooling plates under the conveyor. For Snickers, the nougat is cooled to the perfect temperature, elastic yet non-sticky. This step slightly hardens the nougat, making it easier to apply the caramel layer. The width and thickness of the ribbons are adjustable depending on the bar size. For instance, thinner ribbons are made for Snickers Mini compared to the standard size. Once ready, the nougat is either cut into portions or processed further with caramel and peanuts. And just like that, every Snickers bar begins its journey as a smooth ribbon of nougat. After the nougat cools, it's time for the caramel layer. The caramel is heated and evenly spread over the nougat. This layer adds a smooth sweetness to the bar. Applying caramel onto hardened nougat looks almost magical, but it's really the result of precision engineering. Caramel is prepared separately in massive kettles, where sugar, syrup, and milk ingredients are mixed. The mixture is heated to about 280 degrees Fahrenheit, making it flowy, but not too runny. Maintaining a steady temperature is crucial for the texture and quality of the caramel layer. The hot caramel is transported through special pipes to an applicator above the nougat conveyor. Picture this, it's like a chef drizzling sauce, but on an industrial scale. The caramel flows through special nozzles or combs, which spread it perfectly over the nougat ribbons. These nozzles ensure just the right amount of caramel is applied. No gaps, no excess. Sometimes, tools like blades or vibrating mechanisms smooth out the caramel to perfection. Once the caramel is applied, the ribbons move into a cooling chamber, where the caramel hardens just enough to create that soft yet firm texture we love in Snickers. The temperature in the chamber is carefully controlled to prevent sugar crystallization. The caramel layer isn't thick, but its amount is calculated to balance perfectly with the nougat's flavor. This is one of the secrets behind Snickers' harmonious texture. After cooling, the caramel becomes a stable base for the next step, adding peanuts and finally the chocolate coating. The third layer is peanuts. Each Snickers bar contains about 16 whole peanuts, evenly scattered on the caramel base to ensure every bite is crunchy. The peanuts used for Snickers undergo strict selection. Only perfectly whole, roasted and shelled nuts make it to production. The peanuts are roasted to a golden brown to enhance their flavor and crunchiness. They're sorted by size, and any broken or tiny pieces are removed because Snickers is known for its big, bold peanut chunks. The prepared peanuts are delivered to the production line through hoppers, large containers that act like giant dispensers. These hoppers automatically measure out peanuts to ensure each section of the caramel ribbon gets an even portion. Dispensers above the caramel ribbons work like massive sieves, evenly sprinkling the peanuts to create a dense yet orderly layer. Sensors above the conveyor check that the peanuts are distributed evenly. If any spots are missing peanuts, the system automatically adds more. Once the peanuts are in place, the ribbon is briefly cooled. This cooling step sets the caramel enough to lock the peanuts in place for the next step, chocolate coating. Coating the bar in chocolate is the ultimate moment in Snickers production. First, you see the chocolate waterfall, a cascade of warm, glossy chocolate flowing like a miniature fountain. The chocolate is kept at an ideal temperature of about 113 degrees Fahrenheit in giant tanks. This ensures it's liquid enough to coat the bar, but thick enough to form a solid layer. As the bars pass under the chocolate curtain, they're completely enveloped from all sides. Think of it as giving each bar a delicious chocolate jacket. Excess chocolate is collected by a system beneath the conveyor and recycled back into the tank, like a chef carefully reusing glaze. The most spectacular moment comes next. To create the signature texture on the surface, a special comb or fine-toothed blade passes over the chocolate, forming those familiar wavy patterns. It looks like the chocolate is dancing to the conveyor's rhythm. After the chocolate coating, the bars enter a cooling tunnel. Streams of cold air harden the chocolate, transforming its glossy surface into the firm, matte shell that cracks perfectly with every bite. On average, the Snickers factory produces up to 500 bars per minute. The final step is packaging. The bars are wrapped in foil to keep them fresh and packed into cardboard boxes. From there, they're shipped to warehouses and distributed to stores worldwide. When the bars exit the cooling tunnel, they line up on a long conveyor belt, like a parade, moving toward the packaging station. It's crucial each bar stays in place because the entire process is automated, and every step counts. Next, they head to the wrapping machine, which operates at lightning speed. Shiny foil sheets, not only to protect the bars, but also to give that satisfying crinkle when unwrapped, are cut to size and wrapped around each bar within seconds. The wrapping is so snug, it seals the bar perfectly, like dressing it in its little suit. After wrapping, the bars pass under cameras and sensors that check for flaws. Any defective bars are removed for recycling because quality is non-negotiable. Finally, individually wrapped bars move to the packing machine, where they're grouped into sets, usually 6, 12, or 24. Robotic arms stack the bars into boxes with precision, like playing Tetris. Boxes are sealed with strong tape, stamped with production dates and batch numbers, and loaded into large transport containers. Robotic platforms stack these onto pallets wrapped in stretch film for extra protection. These pallets are then shipped to warehouses and distributed worldwide, from massive supermarkets to small convenience stores. On modern production lines, tens of thousands of Snickers bars are packaged every hour. The process is so automated, human involvement is only needed for oversight. Before the bars hit store shelves, they undergo strict quality control. Visual checks ensure each bar looks flawless, weight tests confirm they meet standards, and, yes, taste tests ensure they're as delicious as ever. Admit it, you're tempted to apply for that job now, aren't you? Thousands of tons of Doritos are eaten around the world every year. Imagine giant harvesters gathering tons of corn to produce 70,000 bags of your favorite snack every single day. Want to find out how ordinary corn kernels turn into the crunchy triangles we all love? Then let's take a trip to the Frito-Lay factory and uncover the secrets behind making one of the world's most popular snacks. Arch West, the head of marketing at Frito-Lay, founded Doritos in the 1960s. He discovered crispy tortillas at a nearby restaurant in San Diego, California. The idea to cut corn tortillas into triangles, fry them, and season them came to him when he had leftover tortillas that couldn't be used because they were broken or didn't meet the standards for sale. The word Dorito comes from the Spanish word dorado, meaning little pieces of gold. Doritos became the best-selling chips in the world in 1988 and remain popular to this day, with 10 different flavors available. The main ingredient in Doritos is cornmeal, which sets them apart from regular potato chips. Corn cobs are carefully harvested from the plants. The cut has to be cleaned to avoid damaging the kernels and to keep the cob intact. Up to 140 tons of corn can be harvested in a single day, ensuring the factory has everything it needs. The stalks are cut just above the ground. Then the cobs are removed and tossed into a container. Once the container is full, the large pile of corn is loaded onto a truck for processing. The supplier cleans and dries the corn kernels. The process involves passing them through a vibrating sieve to remove dust, as well as any stones or sand. The moisture level of the kernels then needs to be raised to 14%, which is critical for the next stage of production, where the corn is sent to the nacho factory. Every day, 99,000 pounds of corn are delivered to the factory. The dried corn is transferred from massive silos into a pot where it is cooked in water. This amounts to over 14.3 million pounds of finished product per year. That's a lot of corn. Frito-Lay operates one of the largest chip-making factories in the world, producing more than 100,000 bags of nachos daily. The factory is divided into 4 main zones. In the corn zone, tortilla products like Doritos are made. At the center is a 700,000 square foot distribution center. About 70,000 bags of Doritos are produced per day, which adds up to roughly 18 million bags annually. Upon arriving at the factory, the first thing you notice are the 2 corn storage silos, each holding 265,000 pounds. From this supply, the factory can produce 44,000 pounds of Doritos. To make Doritos, the corn must be cooked before being placed in the soaking tanks. First, it is boiled in large kettles with stirrers at near boiling temperatures. Then, the corn is transferred into 18 open tanks, where it is left to soak for about 12 hours. Each kettle holds around 660 pounds of corn and about 200 pounds of water. The corn is boiled for about 4 minutes at 200 degrees Fahrenheit, and then left to soak for 12 hours. After cooking, the corn is transferred into large tanks, where it soaks overnight to soften. The corn is left for 12 hours to absorb more water. The soaking process allows the corn to take in moisture and helps remove the hull, the outer shell of the kernels. A machine filters out the water, leaving only soft, hydrated corn. When the moisture content reaches 45% and the hulls are softened and loose, the corn is sent to a washing machine by a pumping system. The loose hulls are removed with a water spray. From the drum, the corn is carried on a conveyor belt to the milling machine. After being cleaned, it enters the grinder, where rotating millstones grind the corn into a dough. The kernels are literally crushed between 2 stones, resulting in a smooth corn paste. During the milling process, water is added to the cornmeal to create the right dough consistency. The dough is checked for 3 key factors: moisture content, temperature, and grind texture. It exits the mill through a small nozzle, forming a thin sheet. This dough sheet is placed between 2 metal rollers. A third roller is responsible for cutting the dough into individual triangular nachos. The dough sheet passes through rollers with triangle-shaped indents. First, it goes between the 2 rollers, then through a cutter that gives Doritos their signature shape, much like a cookie cutter. The sharp edges of the roller cut the dough into perfect triangular pieces. This machine can cut 6,000 chips per minute, producing over 8 million chips a day. The cut chips are placed on a conveyor belt that carries them to the next stage, the oven. Although the process is well designed, there's always some leftover dough, but it doesn't go to waste. It's sent right back to the dough vats to start the process all over again. Now it's time to cook those tortillas. The triangular chips are placed in an oven at 644 degrees Fahrenheit. However, this isn't just any oven. It has 3 temperature levels and reaches several hundred degrees. The nacho triangles spend only a few seconds in the oven to give them the right texture and prevent drying out, while sealing in moisture that creates the signature Doritos bubbles. The industrial oven seals the outer surface, locking in moisture, which causes the dough to puff up and form bubbles. This is what makes Doritos so crunchy. 16 seconds in the oven is enough to dry the dough just enough so it doesn't break when handled. The bumpy texture of Doritos is a result of the heat pulling small moisture bubbles to the surface of the dough. The tortillas are then cooled on several conveyor belts and sent to the fryer. This brief pause also allows inspectors to check that none of the tortillas burned in the oven. The triangles are fed into the fryer on a conveyor belt. The oil is heated to 360 degrees Fahrenheit, and the nachos are fried for 55 seconds. During this time, the nachos develop the perfect color and texture. The bubbles on a finished Dorito are air pockets formed during the frying process. They are then removed using a mesh conveyor belt. As they come out, the fryer is filled with leftover oil. Next, the Doritos are transferred using vibrating conveyors into a special drum, where they are mixed with the right seasonings and ingredients. At the next station, a screw conveyor feeds the nacho seasoning into the drum. Huge bags of the seasoning mix are added to the top of the machine, and a hopper containing the secret blend of cheddar cheese, Parmesan cheese, and spices is placed into the drum. Various cheeses, spices, flavor enhancers like monosodium glutamate, and preservatives are the key ingredients that extend the product's shelf life. To make the surface of the nachos stickier so the seasoning adheres, some nozzles coat the nachos with canola oil. Despite how intimidating the large drum might seem, it evenly distributes the seasoning. The delicate chips are handled in a way that prevents them from breaking apart while moving through the drum. To ensure they are fully cooled before packaging, the seasoned Doritos move along a 98-foot conveyor belt. Once the nachos exit the drum, they head to the packaging section. Through hoppers, they are directed to various packing machines. The highlight of technical choreography is the packaging device. Each machine has 14 bucket scales. The Doritos are positioned, then pass through a weighing machine where a series of scoops accurately measures the weight of each bag of Doritos. A trapdoor opens, releasing the nachos, and the machine forms a strip of aluminum and plastic into a bag once enough chips are ready for packaging. The nachos drop into the bag, which is sealed and cut using heat, as the bottom of the next bag closes. Nitrogen is pumped into the bag, which is then sealed airtight. This process prevents oxygen loss, keeping the Doritos fresh for an extended period, and creating an air cushion to prevent the chips from breaking. Each large bag of Doritos contains about 100 chips. An operator ensures that each box holds 8 bags. The plant's production and packaging output of 70,000 bags of Doritos per day adds up to more than 18 million bags per year. Do you think mayonnaise is just a simple mix of oil and eggs? What if I told you it can polish furniture and elevate your culinary creations to new heights? Today, I'll reveal the secrets behind making America's favorite mayonnaise at the Hellmann's factory and share tips that will blow your mind. Don't miss out. At this factory, thousands of pounds of mayonnaise are produced every day. But the journey to creating this popular sauce starts long before the ingredients even reach the facility. The quality of the final product is directly tied to the raw materials, which is why suppliers are carefully selected. The key components of mayonnaise are vegetable oil, egg yolks, vinegar or lemon juice, and seasonings like salt and mustard. Each of these ingredients plays a crucial role in achieving the perfect taste and texture. The first step in production is sourcing and preparing the ingredients. I watched as vegetable oil was pumped from massive storage tanks into the production area using powerful pumps. Before it's used, the oil goes through additional filtration to remove any potential impurities that may have gotten in during storage. At the same time, pasteurized egg yolks are taken out of the refrigeration units and gradually brought to room temperature. This step ensures they mix more easily with the other ingredients. Vinegar or lemon juice is carefully measured and mixed with water in the correct proportions to achieve the desired level of acidity. This mixture is then combined with salt, mustard powder, and other spices in a special tank for pre-mixing. Everything is thoroughly blended to ensure the dry ingredients are evenly distributed and completely dissolved. When all the components are ready, it's time for the magic to happen: emulsification. Emulsification is the process of combining two liquids that normally don't mix, like oil and water. This is where egg yolk proteins come in as natural emulsifiers. I was amazed by the enormous industrial blenders, known as homogenizers, used for this process. These machines are equipped with powerful mixers and temperature control systems. The process starts with loading the egg yolks into the blender, where the mixers begin spinning at an incredible speed. Then, the vinegar and spice mixture is gradually added. Once the yolks and vinegar are fully combined, the most crucial step begins: slowly adding the oil. The oil is added very slowly, in a thin stream or sprayed, while the mixers continue operating at high speed. This allows the egg yolk proteins to effectively coat the tiny droplets of oil, creating a stable emulsion. This is how the creamy smoothness we all know and love in mayonnaise is achieved. Temperature control during this process is crucial. The temperature is maintained between 68 and 77 degrees Fahrenheit using special cooling systems built into the homogenizers. Once the emulsion is ready, the mayonnaise undergoes an additional mixing stage to ensure uniformity. The mixture is pushed through tiny openings under high pressure, further reducing the size of the oil particles and enhancing the product's consistency. Next, the mayonnaise moves to real-time quality control. Automated systems take samples from the product stream and run quick tests to check for consistency, acidity levels, and appearance. This ensures that the mayonnaise meets all required standards before moving on to the next stage. After passing quality control, the mayonnaise is pumped into temporary stainless steel tanks. At this stage, additional ingredients can be added to create different variations of mayonnaise, like herbs, spices, or other flavorings. Before packaging, the mayonnaise goes through a process to remove any trapped air. Air pockets can not only affect the appearance of the product, but also speed up spoilage due to oxidation. To prevent this, the mayonnaise is placed in special vacuum chambers where all the air is gently removed from the product. Now we move on to the packaging stage, which is equally impressive in terms of technology. The factory is equipped with state-of-the-art packaging machines capable of handling various types of containers, ranging from small glass jars to plastic bottles and large containers for food service establishments. Before filling, each container undergoes thorough cleaning and sterilization. Glass jars are rinsed with hot water and dried with purified air, while plastic containers, which arrive pre-sterilized, are inspected and blown with filtered air to remove any dust particles. The mayonnaise is carefully pumped from the temporary tanks into the packaging machines. The filling process is highly precise to ensure each container receives the exact same amount of product. To prevent air bubbles from forming, the nozzle is slightly submerged in the mayonnaise and rises as the container fills. Once filled, the containers are sealed airtight. For jars and plastic containers, this involves securing lids with precise torque control to guarantee a perfect seal without damaging the container. For soft packaging, heat or ultrasonic sealing is used to ensure a secure closure. The containers are then moved to the labeling stage. Automated machines carefully apply the labels, ensuring precise alignment and no defects. Afterward, each container undergoes a final visual quality check using high-speed cameras and machine vision systems. This ensures that the product fully meets standards before being sent to the warehouse for further shipping. During my visit to the factory, I also learned a lot of interesting things about the history of mayonnaise. It turns out that its origins date back to the 18th century. According to one popular story, in 1756, during the 7 Years' War, after defeating the British in Port Mahon on the island of Minorca, the chef of the Duke of Richelieu created a sauce made from eggs and oil to celebrate the victory. The sauce was named Mayonnaise, after the city of Mahon. Other sources claim that the sauce already existed in French cuisine and derived from the Old French word moyeu, meaning egg yolk. Either way, mayonnaise quickly gained popularity in France and then throughout Europe. In the early 20th century, with the rise of industrialization, mayonnaise began to be produced on a large scale, making it accessible to the masses and helping to spread it around the world. Now, I'd like to share a few fascinating facts about mayonnaise that really surprised me. Did you know that in Japan, mayonnaise is considered a true delicacy? The Japanese use it not only in salads but also in unexpected dishes like pizza, sushi, and even ice cream. Japanese mayonnaise, such as the popular brand Kewpie, has a richer flavor thanks to the use of rice vinegar and extra egg yolks. Mayonnaise isn't just for food. It can be a helpful household item too. It's used to remove sticker or label residue, polish wooden furniture, and even as a moisturizing hair mask. Thanks to its oil and egg white content, mayonnaise nourishes and hydrates hair. In some countries, mayonnaise is preferred over ketchup as a dipping sauce for French fries. For instance, in Belgium and the Netherlands, fries are traditionally served with mayonnaise, and this is considered a classic pairing. Mayonnaise can also improve your baking. Adding it to cake or cupcake batter makes the final product more moist and tender. This is because mayonnaise contains oil and eggs, which enhance the texture of the dough. The largest Olivier salad ever made used a massive amount of mayonnaise. In 2012, a team of chefs in Moscow set a world record by preparing a salad weighing over 4,000 pounds. They used more than a ton of mayonnaise to achieve this. After visiting the Hellmann's factory, I gained a new appreciation for this everyday sauce. From its meticulous production process to its rich history and surprising uses, mayonnaise is far more interesting than it might seem at first glance. So, the next time you spread it on your sandwich, take a moment to think about the craftsmanship behind each jar. Heinz is a brand that has conquered the world. Just imagine. 11 billion bottles of ketchup are sold every year, And every second bottle in the United States is a Heinz. But what is this ketchup really made of? What drives such incredible success? And what secrets are hidden in every drop? Keep reading to uncover all the mysteries behind this iconic sauce. The main ingredient in Heinz ketchup is tomatoes. The production process starts with the careful selection of raw materials, where Heinz applies strict standards for choosing ingredients. Heinz uses special varieties of tomatoes grown exclusively for making ketchup. These tomatoes have a high content of natural sugars and acids, which gives the product its unique flavor. The tomatoes are cultivated on certified farms that follow strict environmental standards. By the way, did you know that the first ketchup recipe, which came from Asia, wasn't made from tomatoes? The recipe has completely transformed over time, allowing us to enjoy the wonderful sauce we have today. So, let me continue. Before purchasing the tomatoes, each batch undergoes laboratory testing to check for nutrients, acidity levels, and compliance with safety standards. Only the best tomatoes are used to make Heinz ketchup. In addition to tomatoes, other ingredients like sugar, vinegar, salt, spices, and natural flavorings are used in the recipe. All of these components are also rigorously tested to ensure they meet quality standards. Once the tomatoes are selected, they are transported to the factory for initial processing. At this stage, the tomatoes undergo thorough preparation before further refinement. First, they arrive at an automated line where they are washed using water sprays. This process takes place on a conveyor belt, allowing a continuous flow of tomatoes to be cleaned. Highly efficient water systems are used to remove dirt and dust from each tomato. On the conveyor belt, the tomatoes are sorted by quality and size. Optical sensors are employed to automatically reject any tomatoes that do not meet the standards. Any defective tomatoes are either sent for reprocessing or disposed of. The remaining tomatoes go through machines that peel off the skin. This often involves a process called thermal treatment, blanching, where the tomatoes are briefly heated to make the skins easy to remove. After peeling, the tomatoes are ground into a puree. This is done with special grinding machines that break down the flesh into small particles. The tomatoes are transformed into a smooth mass, which will later be used to make ketchup. Interestingly, until the 1990s, ketchup was mainly used as an ingredient in cooking. People baked pies, fish, and meat with it. It wasn't until the introduction of hamburgers, hot dogs, and French fries that ketchup became a standalone sauce. So we can thank the Germans and Belgians for inventing those foods. At this stage, the tomato puree is blended with other ingredients to make Heinz ketchup according to its classic recipe. The preparation process also involves automated systems that ensure continuous production. Into the pre-prepared tomato puree, other ingredients like sugar, salt, vinegar, and spices are added. The dosing process is handled by automatic dispensers, which precisely measure the amount of each ingredient to achieve the perfect flavor. Once all the ingredients are added, the puree is transferred to large mixers. Here, the mixture is thoroughly blended until it reaches a smooth, uniform consistency. The mixing machines are equipped with blades that rotate at high speeds, ensuring the ingredients are evenly incorporated. To ensure a long shelf life and eliminate harmful microorganisms, the mixture goes through a pasteurization process. The ketchup is heated to high temperatures, usually around 194 to 203 degrees Fahrenheit, which helps preserve its freshness without the need for artificial preservatives. This process is controlled by automated systems that maintain the exact temperature and processing time needed. Conveyor systems play a crucial role in ensuring the seamless production process at Heinz factories. Here's how the conveyor system works across different stages of ketchup production. One of the most important steps is the transportation of raw materials. All ingredients, tomato puree, sugar, vinegar, and other components, are moved along conveyor lines to the mixing stations. This helps maintain precise dosing and speeds up the process. After the ketchup is prepared, it is transported via conveyors to the packaging department. But before I dive into the packaging process, here's an interesting tip. Did you know you can clean and polish metal items with ketchup? Its ingredients make it an eco-friendly and natural cleaning solution. Simply rub ketchup onto your pots, let it sit for about 10 minutes, then rinse it off with clean running water. I keep meaning to try this hack myself, but I always end up eating the ketchup before I get the chance. Now, back to packaging. It's a fully automated process that involves several steps: filling the bottles, capping, and labeling. Let me break them down for you in more detail. Bottle filling. The ketchup is poured into pre-prepared, sterilized bottles. Automated machines precisely control the amount of ketchup in each bottle, preventing both overfilling and underfilling. Fun fact: a ketchup fan once set a world record by drinking an entire bottle in just 32.27 seconds. Capping. After the bottles are filled, they are automatically sealed with caps. Automated capping machines ensure each bottle is tightly and securely closed. Labeling. Immediately after capping, the bottles are sent to labeling machines, where each bottle is affixed with a label. The machines carefully position the labels to ensure a neat and polished appearance for the product. One of the most critical stages is quality control during ketchup production. Throughout the conveyor line process, automated quality control systems are in place. Sensors and cameras inspect the fill level of the bottles, the tightness of the caps, and the accuracy of the labeling. If a defective bottle is found, it is automatically removed from the conveyor line. To ensure a long shelf life for ketchup, the bottles undergo a final sterilization process after packaging. First, the bottles of ketchup are placed in autoclaves, where high temperatures and pressure are applied to complete the sterilization of the product. This process eliminates any remaining microorganisms that may have survived pasteurization, ensuring the product's safety without the need for preservatives. After the heat treatment, the bottles are cooled to room temperature. This process is also automated and carefully monitored to prevent any thermal damage to the bottles. I should also mention the benefits of ketchup for those looking to lose weight, as 3.5 ounces of the sauce contain only 112 calories. Once all stages of production are complete, Heinz ketchup is prepared for shipment to warehouses and retail locations. The finished ketchup bottles are transported from the production line to the warehouse using automated systems. At the warehouse, the products are sorted by batches and expiration dates. Special pallet systems are used to store the bottles at controlled temperatures to prevent any damage or loss of quality during storage. Heinz also has a well-organized logistics system that ensures product distribution worldwide. This process relies on modern automated tracking systems to monitor the movement of goods. The products are distributed through distribution centers and delivered to stores, supermarkets, and specialized retail locations. Strict transportation conditions are maintained to preserve the quality of the ketchup during transit. As I mentioned before, quality control is an integral part of every stage of Heinz ketchup production. Every step, from selecting the tomatoes to packaging, is monitored using advanced technologies and automated systems. The key quality control measures include laboratory analysis of ingredients, temperature monitoring, and inspection of the finished product. Every ingredient that enters the production process is tested to meet safety and quality standards. During heat treatment, the temperature is constantly monitored to ensure product safety and preserve its flavor. After pasteurization and sterilization, the finished ketchup undergoes further testing to ensure it meets quality standards, including checks for thickness, color, taste, and consistency. The Heinz logo adorns every third bottle of ketchup worldwide, and in the United States, it's on every second bottle. Heinz is one of the foremost recognized food brands globally. Each year, Heinz sells 11 billion bottles, which is roughly 2 bottles for every person on Earth. Founded in 1869, the company has remained at the forefront of the food industry by constantly evolving and maintaining high-quality standards. Just think about it, 155 years on the market. An impressive figure, right? Heinz operates 74 factories worldwide and distributes its products in more than 200 countries. They were also among the first to expand internationally, and today they hold around 30% of the global ketchup market. In fact, Heinz is considered a pioneer in many production trends. They increased the number of bottles produced per worker from 350 to 3,500. Heinz was also the first to introduce cleanliness in production. Before that, it's hard to imagine the unsanitary conditions where food was made. Additionally, they significantly reduced the use of preservatives in their products. The Heinz family tirelessly worked on automating their factories and created a real assembly line long before Henry Ford. The company has also received numerous medals and awards for advertising their products. Moreover, Heinz had to defend their original bottle designs in court to protect their unique shape for ketchup bottles. Imagine a company at the center of a major scandal, but instead of fading away, it turns the challenge into an opportunity. Fairlife went from facing accusations of animal cruelty to becoming a leader in the dairy industry by implementing new ethical standards and winning back consumer trust. This is a story about how a crisis can become the starting point for positive change. Ready to learn how they managed to change the game and set new industry standards? Let's dive into this fascinating journey of transformation. Like any production process, Fairlife's manufacturing begins with collecting the main ingredient, milk. Fresh milk is sourced from farmers who adhere to high standards of animal welfare and product quality. Once the raw milk arrives at the plant, it undergoes the critical process of ultrafiltration. Ultrafiltration is a key stage in Fairlife's milk production that allows the separation of proteins, calcium, lactose, and other components. This process serves multiple purposes, removing some of the water from the milk, which makes the product more concentrated, significantly reducing the lactose content, making the milk suitable for people with lactose intolerance, and increasing the protein content by about 50% compared to regular milk. The ultrafiltration process is carried out using special membrane filters. These filtration systems utilize ultra-thin membranes through which the milk is passed under pressure, removing excess water and concentrating essential nutrients. After this, the milk moves into separators that help further divide the milk's components into different fractions, ensuring the right concentrations of protein, calcium, and fats are achieved. The next stage in Fairlife's production is fortification. This is the process of adding extra nutrients, such as vitamins and minerals, to the milk to boost its nutritional value. Common additives include vitamins D and A, calcium, and other beneficial components. These nutrients are introduced in either liquid or powdered form using special mixers. Before being added, the supplements are dissolved to ensure even distribution throughout the milk. Here's how the process works. Dosing devices calculate the required amount of additives based on the volume of milk being processed, which varies depending on the plant's capacity. The machine then measures the correct amounts of vitamins and minerals and introduces them into the ultra-filtered milk. Afterward, a giant mixer, known as a homogenizer, blends the liquid thoroughly to ensure even distribution of the additives, preventing clumping or uneven concentrations. Once mixing is complete, samples are taken for quality testing. This timely quality control step ensures that the nutrients are evenly distributed and meet established standards. The next stage is pasteurization. This is an automated process in which milk is treated at high temperatures to eliminate harmful bacteria while maintaining its freshness and nutritional value. Honestly, I was amazed at how much happens at the plant. You might think it's as simple as getting the milk from the farmer, bottling it, and that's it, right? But meanwhile, the ultra-filtered and fortified milk flows through pipes into the pasteurization block, where it pours into prepared containers. In the pipes, the milk passes through heat exchangers, where it's quickly heated by hot water or steam to 170 degrees Fahrenheit for 15 to 20 seconds. This quick heating process kills most pathogenic organisms. As for the remaining few, well, nothing is ever 100% sterile, just something to live with. After heating, the milk is rapidly cooled to about 40 to 42 degrees Fahrenheit, which helps preserve its freshness and prevents bacterial growth. The cooling happens in the same exchanger, but this time using cold water that circulates around the pipes. The pasteurized milk is then transferred into sterile storage tanks, where it waits until it's ready to be packaged. The finished milk is packaged into special airtight containers that ensure freshness and long-term storage. By the way, here's a personal tip. Always check the seal of the packaging before you buy it. Once, I failed to do this while visiting my parents for a family dinner, and let's just say the upstairs bathroom got a lot of use. But that's another story. After pasteurization, the milk is transferred from storage tanks to the conveyor belt through pipelines. There, It enters an automated packaging system that controls the entire process. On the packaging line, machines automatically supply and form either cardboard or plastic containers. The packaging is sterilized with ultraviolet light or steam to kill any potential microorganisms. Fairlife milk is dispensed into the prepared containers by high-precision dosing machines, ensuring that each container receives the exact same volume. Once filled, each container is hermetically sealed to prevent air from entering and to maintain the milk's freshness. Depending on the type of packaging, sealing is done using either adhesive or heat. After the containers are securely sealed, important information like the production date, batch number, and expiration date is printed. This labeling is done directly on the packaging line using either a laser or inkjet printer. The packaged containers go through automated sensors and cameras, which check for defects, proper sealing, and compliance with standards. Once inspected, individual containers are grouped into larger bundles or boxes for easier transportation. Robotic systems swiftly and accurately assemble these group packages. The finished bundles are then automatically stacked onto pallets, ready to be stored in the warehouse or sent directly to retail locations. I swear, friends, I've never seen packaging quite like Fairlife's anywhere else. It's so futuristic. It stands out from regular milk cartons as if it was dropped straight from a spaceship onto your table. Fairlife processes millions of gallons of milk each year to meet the demand for its products in the United States and other countries. Thanks to ultrafiltration, Fairlife milk contains 50% more protein and 30% more calcium compared to regular milk. Each serving of Fairlife provides approximately 13 grams of protein per glass, making it popular among people who follow a healthy lifestyle. Fairlife is actively promoted as a healthier alternative to regular milk due to its high protein content and reduced sugar levels. The company works with small family farms, ensuring high-quality milk and supporting the well-being of farming families. Thanks to its specialized processing, Fairlife milk has a longer shelf life, up to 90 days, compared to regular milk. The company emphasizes environmental responsibility by using technologies that reduce water and energy consumption during production. Fairlife quickly became one of the leaders in the ultra-filtered milk market thanks to its innovative approach. However, the company found itself in the spotlight after allegations of animal cruelty at its supplier farms surfaced. In response, Fairlife took action to improve animal welfare and implemented new standards for monitoring its farming partners. The company is actively working to regain consumer trust by introducing initiatives aimed at enhancing animal well-being. Fairlife continues to expand its product line, adding flavored milk options, yogurts, protein drinks, and other dairy products. Imagine a place where time seems to stand still. Deep underground, nestled in the mountains of Pakistan, lies one of the most remarkable mines in the world, the Kura Salt Mine. This place is more than just a mine. It is the largest producer of pink Himalayan salt, renowned for its purity and rich mineral content. The Kura mine is an expansive underground complex made up of numerous tunnels and chambers where salt extraction continues without interruption. From the very beginning of my journey, I felt as though I had entered another world. The entrance to the mine looks like a gateway to an ancient, almost magical realm. Here, they extract some of the purest salt on Earth, the famous pink Himalayan salt. Let's walk through the old tunnels together and discover how this remarkable process takes place. The walls of the mine are lined with layers of pink salt, and each layer tells its own story, preserving the memory of millions of years of geological activity. The sense of descending deep into the earth is heightened by the near silence, broken only by the echo of footsteps and the hum of machinery at work. Salt extraction at the Kura mine is carried out using traditional methods that have changed very little over the past 200 years. It all begins with drilling holes into the salt walls. Miners use powerful drilling machines to bore holes into the rock. Drilling is a crucial and delicate step, as the precise placement of the holes determines the efficiency of the entire process that follows. Once the holes are ready, the workers carefully insert gunpowder capsules into them and connect them with wires. This must be done with extreme precision to ensure that the blast does not compromise the structure of the mine or create safety hazards. For each borehole, they use 4 capsules. Once all the charges are set, the blast occurs, separating large chunks of salt from the wall. This process requires great accuracy and skill to avoid damaging the surrounding salt layers and to maintain safe working conditions. After the explosion, the cleanup phase begins, which is also a labor-intensive task. Workers use special equipment and manual labor to carefully sift through the debris, selecting the best pieces of salt. This phase can take several hours, and sometimes an entire day, depending on the volume of salt being extracted. After the explosion, workers use excavators to clear away the large chunks of salt. The excavators lift these blocks onto special carts, which then transport the salt to the sorting area. Here, the highest quality pieces are carefully selected by hand. This process is time-consuming and requires great attention to detail to ensure that only the best salt makes it to production. The miners break the salt into smaller pieces, which are then meticulously sorted for further processing. It is remarkable how crucial the human element is in this operation. Only experienced workers can determine which pieces of salt are suitable for refining. They assess the color, clarity, and texture of the salt to choose the best material. Working in the mine is not only physically demanding, but also dangerous. Humidity and temperature in the mine often fluctuate, and the salt can become slippery. Miners must remain vigilant at all times to avoid injury. Despite the challenges, they take great pride in their work, knowing that their efforts benefit millions of people around the world. Once the salt has been brought to the surface, the next phase of processing begins. First, the salt is sorted by size and color, with only the purest and most visually appealing pieces moving forward. Then, the salt goes through a washing stage. Large chunks are submerged in huge vats of water, where they are thoroughly washed to remove any impurities. This step is crucial to maintaining the product's high quality and ensuring its cleanliness. The washing process is repeated several times until only the purest salt crystals remain. Each cycle is carefully monitored to ensure that every grain meets strict quality standards. Washing is one of the most labor-intensive stages, as the salt must then go through the drying process. First, the salt is pressed to remove excess water, and then it is placed in special drying chambers where it slowly dries. This method helps preserve the salt's natural structure and unique properties. It's essential that the salt remains as natural as possible, and the washing process, free of chemical additives, guarantees this. One of the most fascinating stages of salt processing is the creation of Himalayan salt lamps. Craftsmen carefully shape large chunks of salt by hand, giving them a variety of forms. Each piece is given a unique shape. Some lamps retain a rough, natural look, while others are crafted into smooth spheres or pyramids. After shaping, the salt is washed again to remove any remaining impurities. Then, the craftsmen insert electrical components, transforming the salt block into a lamp that emits a soft, warm glow. The process of making salt lamps begins with selecting the right chunk of salt. Using specialized tools, artisans shape the piece, a process that can take several hours, since each salt block is unique and requires an individualized approach. Once the shape is finalized, a hole is drilled into the salt to accommodate a light bulb, and the electrical components are installed. Every lamp undergoes a quality check to ensure it is safe and built to last. In addition to lamps, the factory also produces other salt items, such as bowls and pyramids. These pieces are handmade, making each one a unique work of art. The lamps come in various sizes, ranging from small to very large, with some weighing up to 20 or 30 pounds. These creations serve not only as beautiful interior decorations, but also as sources of comfort and warmth in the home. Each product is subject to strict quality control, and only those that meet high standards are made available for sale. After the salt goes through the stages of sorting and washing, it is ground into fine crystals. The salt is then sent to the purification stage, which involves several additional steps. The crystals are passed through large rotating drums, where they are heated to remove all moisture, making them dry and ready for use in the kitchen. This process is crucial for preserving the flavor and quality of the salt. Each step of the processing is carefully designed to ensure the final product is of the highest quality. After drying, the salt undergoes a grinding process. Special mills are used to crush the larger crystals into smaller ones. The salt is then sifted to separate any particles that are too large. These larger particles are sent back for further grinding to achieve a uniform consistency. This step is important to ensure the salt is convenient for kitchen use and has crystals of a consistent size. Once the grinding is complete, the salt is checked for impurities. It is passed through magnetic separators to remove any metal particles and through optical sensors to detect other contaminants. Only after the salt has passed all inspections is it sent for packaging. After all the processing stages, the salt is ready for packaging. First, it is packed into large bags for bulk distribution, and then it is portioned into jars or packets for consumers. Each packet retains the salt's beautiful pink hue, a sign of its natural origin and rich mineral content. Workers manually inspect each package to ensure everything is done correctly, and the product quality remains top-notch. It's a meticulous job, but this careful inspection ensures consumers receive a high-quality product. At the packaging stage, modern equipment is used to speed up the process and minimize direct contact with the salt, which is essential for maintaining its purity. The salt is packaged in various forms, from small plastic jars to large bags for restaurants and food industry businesses. After packaging, each batch of salt is labeled with the production date and expiration date, so consumers can trust the quality and freshness of the product. It's said that Himalayan salt lamps help purify the air and reduce radiation from electronic devices. While there is little scientific evidence to support these claims, many people find that the ambience created by these lamps does help them relax. As for Himalayan salt used in food, it contains about 84 minerals, including magnesium, potassium, and calcium. These minerals can help maintain balance in the body, improve digestion, and regulate fluid levels. Incorporating Himalayan salt into your diet may be a beneficial addition to a healthy lifestyle. Himalayan salt is also known for its therapeutic properties. Some people use it for salt baths, which help with relaxation and can improve skin condition. Additionally, it's used in salt inhalation therapy for respiratory issues. Its natural composition and lack of chemical additives make it a preferred choice for those focused on their health. Himalayan salt also has a milder, more complex flavor compared to regular table salt, making it popular among chefs and food enthusiasts. Chupa Chups isn't just a lollipop, it's a global legend. Every day, the factory produces over 12 million lollipops, which are exported to 150 countries. And it all began in 1958 with a simple idea: adding a stick. From meticulously testing ingredients to the iconic logo designed by Salvador Dali, Chupa Chups knows how to make an impression. Ready to see how the taste of childhood is created? Let's dive in. The Chupa Chups company was founded in 1958 by Spanish entrepreneur Enrique Bernat. He introduced the concept of a lollipop on a stick, making it easier for kids to enjoy candy without getting their hands sticky. Enrique came from a family of confectioners. Before creating Chupa Chups, he worked for a company that produced traditional candies. At some point, he realized that regular candies posed a challenge for children. They often got their hands dirty or spent too much time unwrapping and handling the candy. His idea was to create a treat that could be enjoyed without touching it directly. The solution came quickly: attach a wooden stick to the candy. This innovation made the process of eating candy both simple and hygienic. Originally, the lollipop on a stick was called gol, from the Spanish word for goal, hinting at the idea that the lollipop resembled a ball, and the mouth was like a goalpost. It wasn't until the 1960s that the brand adopted its modern name. The word chupa comes from the Spanish verb chupar, meaning to lick, highlighting how the product is consumed. The simple slogan, Chupa un chups, which translates to lick a chups, was straightforward yet catchy in my opinion. The main ingredients of a Chupa Chups lollipop include sugar, glucose syrup, acids, citric or malic, flavorings, and natural or synthetic colorings. Quality control starts with the raw materials. The company only works with suppliers who hold certifications that meet international standards. Before establishing a partnership, they inspect the production, transportation, and storage processes. This involves factory and warehouse inspections. Inspectors evaluate the appearance, color, smell, and texture of the ingredients. For instance, they check for lumps in the sugar, any off odors in the syrups, and whether the colorants meet specified standards. I find this level of meticulous attention to detail truly impressive. Next come the physical and chemical tests, such as measuring the moisture content of the sugar, checking the acidity of citric or malic acid, and analyzing the glucose concentration in syrups. Naturally, microbiological testing is also conducted. This involves checking for harmful microorganisms, such as bacteria, mold, and yeast, that could compromise product safety. Additionally, the ingredients are tested for the presence of heavy metals, like lead and mercury, pesticide residues, or other harmful substances. Once the ingredients pass inspection, they are stored in specialized warehouses. Storage conditions are strictly controlled. Temperature and humidity levels are tailored to the specific requirements of each type of raw material. Regular monitoring ensures that the ingredients remain in optimal condition, preventing spoilage before they are used in production. The next step involves transforming solid sugar crystals and viscous syrup into a uniform, pliable mass from which the lollipops will be shaped. This requires reducing the water content in the mixture and blending the main ingredients, sugar, glucose syrup, and water, in precise proportions to achieve the desired texture and flavor. The process is carried out in specialized equipment, vacuum kettles, or melting tanks. These machines have double walls for even heating and are equipped with stirrers to prevent the mixture from burning. Temperature and humidity sensors inside the equipment ensure accurate heating, while automatic dispensers precisely measure and mix the ingredients. In a kettle that stands about twice the height of an average person, sugar and water are combined in a ratio of approximately 3:1. Once the sugar dissolves, glucose syrup is added to achieve the optimal texture. The mixture is then heated to around 230 to 250 degrees Fahrenheit. At this temperature, the sugar dissolves fully and the water begins to evaporate. When the mixture reaches approximately 284 degrees Fahrenheit, the process of inversion begins. Some of the sucrose breaks down into glucose and fructose due to the high temperature and the addition of acid. The temperature is then gradually increased to 300 degrees to evaporate most of the remaining water. The consistency thickens and the sugar dissolves completely. The mass is stretched using specialized machines to enhance its transparency and give it a glossy finish. In some cases, a small amount of air is incorporated into the mixture, creating a softer texture and ensuring even color distribution. I was absolutely mesmerized watching the caramel stretching process. As a kid, I would have gladly traded all my toys for a week just to witness that spectacle. Once the main batch of sugar and syrup is ready, flavorings like strawberry, orange, or others are added, along with natural colorings derived from plants and fruits or artificial ones. Citric acid or malic acid is also mixed in to create a tangy taste. If the candy is designed with layers or a mosaic pattern, different colored and flavored batches are combined during the stretching process. For example, the rainbow Chupa Chups are made using a layering technique. It's an incredible process. I'd go back to the factory just to watch it all over again. The threads of caramel are semi-transparent, stretching into beautiful, colorful bundles. I've mentioned this before, but see it for yourself, and you'll understand my excitement. The process of forming lollipops at the Chupa Chups factory is highly advanced and almost entirely automated. Human operators are responsible for monitoring and adjusting the equipment, as well as performing quality checks. But overall, machines handle the heavy lifting. A large sheet of sugar mass is fed into a machine for portioning. There, it is either cut or pinched into small pieces. Each piece is precisely measured to match the exact weight of a single lollipop, typically around 5 to 10 grams. These portions then pass through a mold press, which gives the lollipops their desired shape, whether round, oval, or something else. The molds are cooled to help the candy harden quickly. One of the most crucial steps in the production process is inserting the stick, a key element that made the brand so iconic. This step is also fully automated, with machines ensuring both accuracy and efficiency. Plastic or wooden sticks are automatically fed onto a conveyor, where they are cleaned and inspected for quality. Each stick must be straight, sturdy, and free of defects. The candy mass is then either molded directly around the stick, or the stick is inserted into the center of the still malleable mass. A machine inserts the stick with precise calculations of angle and depth to ensure it is securely fixed in place. Once inserted, the lollipop cools quickly in its mold, creating a strong bond between the stick and the candy. The quality control during this stage includes a visual inspection of shape and size. Machines equipped with artificial intelligence scan the lollipops for defects such as incorrect size, uneven color, or missing sticks. Even the stick's attachment strength is tested. Specialized testers check whether the stick is firmly secured. Each lollipop is also automatically weighed. If the weight falls outside the acceptable range, the lollipop is rejected. After being shaped, the lollipops are transported via conveyor to cooling chambers or cooling conveyors. The temperature is lowered gradually to prevent the candy mass from cracking. Only after this process do the lollipops achieve their final hardness and become ready for packaging. During the final quality check, a specialized tasting panel evaluates whether the lollipops meet expectations. They assess if the flavor is as intended, whether the flavorings are evenly distributed, if the color matches the standard samples, and even check the product's transparency. This part of the tour is usually my favorite, but this time, watching the caramel stretching process took the top spot. Yes, I'd say it 3 more times if I could. I don't know about you, but if someone had told me as a kid that such a job existed, I would have been over the moon. Just imagine, every day you get to taste test your favorite candy. What could possibly be better? Of course, it's not as easy as it sounds. It requires specialized training and a long journey to land that specific role. But if I'd known about it as a child, nothing would have stopped me. Every batch of product comes with its own unique identification number, which allows the origin of each ingredient to be traced. If any issues are discovered during testing or reported by consumers, a thorough investigation is conducted to identify the source, such as a specific raw material supplier. Each Chupa Chups lollipop is wrapped in a special wrapper, a fully automated process to prevent any contact with human hands. Once wrapped, the lollipops are sorted and packed into larger boxes or tubes for transportation to stores. The finished products are then sent to warehouses, where they are distributed to retailers and distributors. Fun fact: the iconic Chupa Chups logo was designed by the famous artist Salvador Dali. He created the bright design featuring yellow and red floral shapes resembling a daisy, and he cleverly placed the logo on the top of the wrapper to ensure it was always visible. This logo has become legendary and remains a key element of the brand to this day. What do a sandwich, potato wedges, and pasta have in common? That's right, cheese. It takes these simple dishes and turns them into pure bliss. There are plenty of cheeses in the world, but cheddar holds a special place in my heart. Today we're diving into my love story with this cheese, my go-to for the easiest, most delicious meals I know. Let's get started. At the cheese factory where cheddar is made, pasteurization is like a technological dance. By the way, are you into techno? The process kicks off with an automated system moving milk through a network of sterile pipes to a pasteurization unit. Here, heat exchangers warm the milk to an exact temperature, typically between 161 and 167 degrees Fahrenheit. It's not just heating, it's a precision process that destroys harmful microorganisms while keeping the milk's nutrients intact. The secret lies in the control system. High-precision sensors continuously monitor the milk's temperature. Once the milk has been heated for the required time, it's cooled down almost instantly to a safe 39 degrees Fahrenheit. Here's where it gets innovative. The heat released during cooling is reused to warm the next batch of milk. This energy regeneration is both cost-effective and eco-friendly, reducing the production's overall energy consumption. In the warm halls of the cheese factory, where the milk has already been pasteurized, the next step begins, adding the starter culture and rennet. The pasteurized milk is poured into large stainless steel vats, where it's heated to around 86 to 89 degrees Fahrenheit, the perfect temperature for the starter culture to do its magic. A computer system controls every detail, from the milk volume to the exact temperature in each vat. The starter culture goes in first. These are carefully selected lactic acid bacteria that give cheddar its signature flavor and texture. Delivered as either a powder or liquid, the culture is measured precisely by robotic dispensers. Once added, large mechanical paddles gently stir the milk, ensuring the bacteria are evenly distributed. Next comes the addition of rennet, a microbiological enzyme called rennin. It's eco-friendly and even suitable for vegetarians. Adding rennet is where the magic happens. It transforms the milk into a curd in less than an hour, laying the foundation for cheddar. While the rennet works its magic, the system keeps an eye on every change in the milk. Sensors measure acidity and density, while algorithms determine the exact moment to end this phase. Modern technology ensures the process is quick, efficient, and requires minimal human intervention. Once the curd is fully formed, the milk is no longer a liquid. It has become a smooth, tender cheese mass ready for the next step in becoming the famous cheddar. Cheddar is the reason I took my first steps in cooking. Actually, I've taken a lot of steps since then, but I still feel like I'm standing in the same spot. But let's not talk about that. Let's talk about 10-year-old me trying to cook for the first time. Picture this. Me, a heated pan. My mom watching from the corner of the kitchen, ready to call 911 if needed. And there they were. 2 slices of bread slathered with butter and a generous slice of cheddar. Sure, the bread got a little burnt, but it still tasted incredible. By the way, what was the first thing you ever cooked? Forming the curd is when cheddar starts to take physical shape. Every parameter, temperature, acidity level, enzyme timing, is carefully monitored. Sensors continuously measure the milk's density to determine when the curd has reached the ideal consistency, which takes about 30 to 40 minutes. Look at this giant vat. The milk seems to have frozen in time, turning into a soft, gel-like curd. Once the sensors confirm the curd's structure, special knives come into play. These are automated paddles fitted with blades that gently cut the curd into small cubes. They move slowly and evenly to maintain uniformity, which is essential for separating the whey later. At the same time, the vat is gradually heated to around 100 to 104 degrees Fahrenheit. This secondary heating helps expel whey and solidify the cheese granules. As the whey separates during heating, it's drained through special valves at the bottom of the vat. This process is also automated, ensuring just the right amount of whey is left to maintain the cheese mass's proper consistency. What remains in the vat is dense yet tender curd, ready for the cheddaring process. You've been waiting for this part, haven't you? The curd, now formed into large chunks, is transferred to special tables or conveyor belts made of stainless steel with built-in heating systems to maintain the optimal cheddaring temperature of around 95 to 100 degrees Fahrenheit. The curd is stacked into layers, distributed evenly by robotic manipulators or conveyor systems. These layers rest for a specific time, allowing them to bond and compress. Under its own weight and the steady temperature, the curd releases residual whey. After a certain period, the layers are flipped over. A key feature of the cheddaring process is the gradual acidification of the curd. This happens thanks to the lactic acid bacteria added earlier with the starter culture. Their activity alters the cheese's chemical composition, giving it a mild, slightly tangy flavor. By the time cheddaring is complete, the curd becomes dense, elastic, and ready for the next step, cutting and salting. Automated cutting systems divide the curd into equal pieces, ensuring consistent weight and size for every portion. At this point, my friend, we're one step closer to achieving cheddar's authentic flavor and texture. Now the curd, firm and springy, moves along specialized conveyors. Come closer and take a look. This is where the curd is cut into blocks or cubes, depending on the intended product. Next, it's time for salting. In the US, two main salting methods are used: brine baths and dry salting. The choice depends on the recipe for each batch of cheddar. In brine baths, large tanks are filled with a salt solution, where the cheese is submerged for several hours to allow the salt to penetrate its structure. For dry salting, the cheese blocks travel along a conveyor, passing through machines that evenly sprinkle salt over them. Salt serves a dual purpose. It enhances flavor and acts as a natural preservative, protecting the cheese from unwanted microorganisms. During this stage, the cheese continues to release residual whey, which automated systems collect and process for further use or recycling. And now, it's time for aging. This, by the way, is something I have zero patience for when it comes to cheddar. The cheese blocks are sent to special aging rooms, also known as maturation chambers. These chambers are equipped with modern climate control systems that automatically maintain optimal conditions for cheddar to age. Temperature, humidity, and air circulation are regulated with precision, down to the 1/10 of a degree or percentage, because even the slightest deviation can impact the cheese's quality. Cheddar is typically aged anywhere from a few months to several years. Young cheddar has a mild, creamy taste, while aged cheddar develops a rich, tangy flavor with a crystalline texture. The aging duration is determined during the batch planning stage, and all parameters are recorded in a centralized computer system. Robotic manipulators carefully stack the cheese blocks on racks in the aging chambers. These robots are programmed to minimize contact with the product, ensuring a high level of hygiene. The rack systems are also automated, capable of rotating or moving the blocks for even aging. Throughout the aging process, the cheese is closely monitored. Automatic sensors in the chambers continuously check the microclimate and even analyze gases released by the cheese to track chemical changes in its structure. In some cases, cheddar is coated with a layer of wax or a special film to protect it from drying out and environmental exposure. For aged varieties, dry aging is sometimes used, leaving the cheese uncovered to form a natural rind. When this method is chosen, automated systems periodically move and flip the blocks, cleaning them of any accumulated dust or mold.